Shooting stars look mesmerizing in the night sky, but they are not really stars. What if I tell you that there are real shooting stars, or stars that zooms through the cosmos at millions of miles per hour? They are called hypervelocity stars. During the English Renaissance, people believed shooting stars were luminaries falling from the heavens and harbingers of calamity. But by the end of 19th century, scientists had established the truth to be far more mundane. What today are commonly called shooting stars or falling stars are simply small pieces of rock or dust that quickly burns up upon entering the Earth's atmosphere. But nature has a surprise for you. Shooting stars really do exist. From 2005 to 2014, a monumental observing program incorporating the Solar and Digital Sky Survey and telescopes at the Fred Lawrence Whipple Observatory confirmed a new class of stars that move with such incredible speed that they can escape the gravity of their home galaxies. Astronomers are just beginning to understand the real-life shooting stars called hypervelocity stars that zooms through the cosmos at millions of miles per hour. The story of hypervelocity stars began in 1988 when Jack Gilbert Hills, a theoretician at Los Alamos National Labs, had an inspired idea. What would happen if a binary star system, that is two stars that are gravitationally bound to each other and orbit a common center of mass, traveled near the massive black hole at the center of Milky Way? Hills calculated that the tidal force of the black hole could rend the binary system in two. Imagine two ice skaters holding hands and spinning around until they all of a sudden let go. The two skaters will fly away from each other. Similarly, when two stars in a binary system are ranged apart by a close encounter in the black hole, they will fly apart. In such an encounter, one star might gain enough energy to be slingshotted out of the galaxy entirely. Astronomers now know that this is how hypervelocity stars are born. But they are not just speeding stars, they have another feature that may make them look like really enormous comets. Well, scientists were surprised to discover that a really fast star can leave a sort of contrail too. Mira, a star that scientists have studied for over 400 years. But NASA's Galaxy Evolution Explorer telescope captured a very surprising image of Mira. It showed for the first time that Mira has a long tail of dust and gas 13 light years long. That's 20,000 times longer than the average distance from Sun to Pluto. A star's life has a beginning, middle and end, just like ours. Only a star's life is much longer. Mira is a red giant star near the end of its life. It is blowing off much of its mass in the form of gas and dust. It has already flung out enough material to construct at least 3,000 Earth-sized planets. Mira is moving at 291,000 miles per hour. This is much faster than the stars in our part of the Milky Way galaxy. The speed and the huge amount of material coming off Mira have created its long contrail-like tail. After the publication of Hill's prescient paper, the astronomy community considered hypervelocity stars an intriguing possibility, although one without observational evidence. That changed in 2005. While observing the stars in Milky Way's halo, a team of astronomers using the MMT Observatory in Arizona came across something most unexpected. They observed a star escaping the Milky Way at nearly 2 million miles per hour. That is HVS1, the first known hypervelocity star. Observations tell part of the story, but to help answer the questions such as what happens to the companion after it separates from the hypervelocity star, Dr. Eden Ginsberg and his team turned to computer simulations. Their models predict that the star in the former pair is often left orbiting the black hole in much the same fashion as the Earth orbits the Sun. Another exciting result from this modeling efforts was the discovery that sometimes the two stars can crash into each other. When this happens, the stars may merge into a very massive star. Well, if you are wondering what might befall to a planet orbiting one of the stars, they modeled that too. In a short paper from 2012, Dr. Eden Ginsberg and his colleagues showed that the black hole in the center of our galaxy can blast planets out of the Milky Way at nearly 5% the speed of light. As of today, no hypervelocity planets have been detected, but they very well might be out there, waiting for some happy astronomers to relocate the James Webb upon them. But not all fast stars leave the galaxy. Utilizing the data from Gaia Spacecraft launched in 2013, they discovered some of the stars that astronomy community had previously considered hypervelocity stars are in fact likely bound to Milky Way galaxy. While this result may sound disappointing, it actually reveals two critical points. First, there are different mechanisms to accelerate stars to high speeds. Today, astronomers know of thousands of speedy stars. However, just because a star is moving fast does not necessarily make it a hypervelocity star unbound from the Milky Way. Secondly, true hypervelocity stars that are escaping the Milky Way may be rarer than previously thought. But stars sometimes behave much more weirdly. Scientists recently found a new kind of death star that is neither a black hole nor a white dwarf. Then what is this?